want to talk about Beer's law. And if you do not have a graphing calculator where you can put in points, then I have two over there. You can borrow one from me, but you're going to need that for the next several units. So what Beer's law says is that you can find the absorbance of something, let me go to a different color. Absorbance. The absorbance of our solution is equal, so A is absorbance, is equal to A times B times C, where little a is our path length. Our path length is how far our light has to go through the liquid before it gets to the sensor. So however big, if you have a test tube, however wide that test tube is, that's your path length. So if you're using the same test tube over and over and over again, then path length is going to be a constant. It's not going to change. B is the molar absorbity, and this is something that is within the machine of what we're going to be using, and that is, if you use the same machine, that's going to be constant. And C is the concentration of our solution. So what happens is, we're going to use a spectrophotometer. And a spectrophotometer, when I used to work in the labs, a spectrophotometer is about this big, about this tall, and it has a little hole in there, that big. And we go, and I would take cells, blood cells or whatever, and put it in there, and then I would take for another sample, and we take samples and we see how much absorbance was in each sample. We would see what the absorbance is. And then we could figure out what the concentration is from that number. So what we want to do is we can take a bunch of concentrations of a known solution. So we can take the concentration of a known solution. Hold on, I'm trying to get to my... And that would be my X. So concentration would be my X-axis. And so if I take something and I dilute it, and I know I take 5 dilutions, and I know those dilutions, then what I can do is I can put it here in my little spectrophotometer, and I can get the absorbance. So I can graph my concentration against my absorbance. And what this comes out to look like is something like that. What we get is we get a standard curve. So if I know the absorbance that each concentration gives, I can take an unknown and I can figure out what the concentration of my absorbance is by using a standard curve. And that's what we're going to do within our lab. So here is a simulation of what's going on in that little spectrophotometer. So here's a drink mix. What color is that drink mix? Does it look pink? Okay, so if we take it and we have our path link, we can change our path link. We can make it wide, however big we want to make it. And then what we can do is we can say, what color do we want this light to put out so that we can get the best absorbance? So if I say, oh, well, it's red. Let's go ahead and use a red light on it. So I'm going to go down here to red. And I'm going to shine my light through there. And we see that we get an absorbance of 0.03, if you see up here at the top. Well, we're not getting very much absorbance. Why aren't we getting very much absorbance? Because you're reflecting the color you're seeing. So what color would be complementary to red if we wanted to get the best absorbance?
Green.
Green. So we can move our light down to, oops, move, down to green. And we can see that our absorbance goes up. All right. What happens to the transmittance? While ago we had, when we were at red, we had 100% transmittance, but now when we go to green, we're only getting 32% transmittance. So we get less light going through there. All right, because it's all being absorbed. All right. So what we can try, we're going to be doing copper sulfate. So copper sulfate's a blue solution, and we can change the molarity of what we're using. I'm not sure. I know we're using 0.4 molar. All right, so what color of light should we use when we are choosing our wavelength? If I look back here at my spectrophotometer, I have 4 different wavelengths that we can use. We can use 430, 470, 565, and 635. So what would be the best one to use? 635 is more red. So we get 0.02 absorbance. If we go over to the oranges, 535 or so.
0.
Oh. It was at 635.
Because it has like, it's both purple.
So maybe let's up our concentration. So maybe right in here might be the best point. We don't want to use the 400s. We're going to want to use either the 500 or the 600, whichever one you kind of decide you want to use. All right, but you're going to be constant on what you're using. So this is something that you can play with. I will tell you big A equals ABC. You will see that on your quiz next week, and you will see it on this bullet lab. You will see it on your test. So knowing how to do these calculations is going to be very important. So now that we kind of know what's going on within that little machine, let's take a look at our pre-lab. Okay, so here is our machine. You're going to use these little cuvettes. You're going to get a cuvette and you're going to have like 5 of them, 6 of them in your little baggie. Use one, all right? Because you're going to standardize on one cuvette, and if you change that cuvette has scratches in it, minute scratches that you don't see, and if you change it to something else, it's going to screw up your data. So you're going to choose one cuvette and you're going to use it throughout the experiment. Also, fingerprints. If you get fingerprints on there, then it's going to screw up your data. So you need to wipe it down after every time you touch that cuvette. So here's a graph. So this is your first question on your pre-lab. What wavelength should you choose to measure the copper concentration spectrophotometrically, and why? So what would you guys choose? If you're looking at your about 620 or so. So approximately 620 nanometers. How come you're not writing? Oh, because it's in white. Oh my goodness. 620 nanometers. And then in your pre-lab, answer why you've chosen 620 and not, I don't know, whatever that is, 800. Any questions on that? So in your pre-lab, you want to answer why you did 620 and not why you chose something else. Okay, the next thing is in your lab, you've got to do a standard curve. So you're going to be given a solution of 0.4 molar copper sulfate. And you're going to have to take that and you're going to have to dilute it from 0.4 down to 0.025 molar. So you're going to have to, I wouldn't worry about not coming up with whole numbers with that. I would worry about doing, say, 3 mils of my copper sulfate with 8 mils of water. I would want to use whole numbers in my dilutions rather than whole numbers on my molarity. Does that make sense? Because you're going to be measuring 10 mils. And trying to measure 5.43 mils of something is harder than measuring 5 mils of something. All right, so we're going to do a standard curve. So we're going to take our concentrations of our solutions. We're going to find the absorbance, and then what we're going to do is we're going to get a standard curve. We're going to get an equation. So in your calculator, what I need you to do is I need you to go in, and I need you to get an equation for me using concentration as your L1 and absorbance as your L2. Once you've got that in there, do a linear regression and get me an equation. So y is equal to, what did you guys get for your A? 1.4. And x and b is negative 0.1? Oh, 1. 0, 1. Okay. 1.4 is our A. That's our little a. That's my path length. 0.01 is my molar absorbity. That is my B. Y is my big A. That's my absorbance. So what is X? C. And C is my concentration. Once you get your standard curve and you have your equation, all you're going to do is you're going to take your bullet juice, take it, put it into your spectrophotometer, and get an absorbance. And then we can plug that absorbance in to figure out what the concentration of copper is. Okay? So your concentration right now is 0.48, or your absorbance is 0.48. Tell me, what is the concentration of that copper ion if you plug that into your equation? What do you get for your copper ion concentration? .35? So, X equals 0.35 big M. That is my concentration of my copper ions. Does that make sense? So Y equals mx plus b. We're going to use that throughout the year in here. Yes?
What was X?
X is my concentration. That's C. And when she solved for it, she got 0.35 molar. I've already told you this, that you are going to have to come up with your dilutions. And your dilutions, you need to make 4 of them. I would start at 0.4 and one needs to go to 0.025. And then you need to figure out how much. We're going to have 10 mils of each one. So on Monday, you need to come in and be ready to run that standard curve. Have your dilutions, your numbers ready. How much water you're going to do for every however much copper sulfate. Any questions on that? Okay. So now, what we're going to do is we're going to do the math to get us there on Monday. So you got your bullet casing, and Monday, when you go in there, examine it, see if there's any markings on there, like maybe who the maker is or that type of stuff. That way you can use it on the day when you figure out who your maker of your bullet was. So get the mass. Well, I am going to go with what I did. I did this over the summer, and my mass of my copper was 0.698 grams. So my little bullet, it was a little 22, was 6.98 grams. And I want to know how much nitric acid do I need to fully dissolve that? Okay, so I need a stoich from copper, from my mass of my bullet, so from the mass of Mariah's bullet, to however much of copper or nitric acid I need. So we're in grams of copper. We're assuming it's 100% copper. So I need to get that to moles. So I need the molar mass of copper. 63.54? 55 grams of copper for every 1 mole. What is our ratio of nitric acid to copper? 4 to 1. So 4 moles of HNO3 for 1 mole of copper. I am going to keep this going. I am in moles of nitric acid, but I have my molarity of my nitric acid. Yes. I would, well, you can go back and watch the video. I am in molarity, moles per liter. So this is 15.8 moles per 1 liter. Everybody understand that? Now I'm going to throw that into my stoich, right, my dimensional analysis right here. I'm in moles, and I need to get to liters because my nitric acid is a liquid. So I'm going to use liters. So what I'm going to do is for every 1 liter, we have 15.8 moles of nitric acid. And that gets me to what? Somebody put that in the calculator for me. How many liters does that give me? Two seven? 2.7 liters. That is very hard to measure in a big liter flask. So I am going to change this to milliliters. So I'm going to multiply that by 1,000 mils for every 1 liter, and that gives me 2.7 milliliters of nitric acid. So to dissolve my little bitty bullet, I need 2.7 milliliters of nitric acid. I want it to be in excess, so I'm going to go ahead and I am going to just add 2 milliliters on top of that just to make it in excess. If you had 15.7, just add 2 milliliters on top of that. So that gives me 4.7. 4.7 is kind of hard to measure, so I'm just going to round that to 5 milliliters of nitric acid.
So we add 2.
I add 2, and I just took it to a whole number. in your lab notes it says add 2 to 3 on top of that to make it in excess in your write-up. So on Monday you're going to come in. I would do this. This would be my first step, is get that bullet melting, and then go and do your standard curve. And then once your bullet is melted, then you move on to the next step and get the absorption of it. Yes.
So instead of like 0.698, we just use the mass that we got.
Yes, exactly. So if your mass was 4.5 whatever, you're probably going to use about 15 mils of nitric acid.
Why do we add 2?
Just to make it in excess. This is just enough to get it to dissolve. We want it to make sure everything dissolves. So we put it in excess. Okay? Are there any questions over that? And then you have question number 5, which says, what if you put your bullet juice into your spectrophotometer and it's off the charts? What are you going to do? You're going to need to dilute it. So if you dilute it by 5, what was your original concentration? Okay? So that is your pre-lab question 5. Any questions with that? Everybody good? I will be home this weekend, probably not doing anything. So if you need help, text me and let me know. And then this will be on homeroom.